Hello and welcome to MakeLearn 360. In this video, I want to solve a couple of problems with you to illustrate the concept of movement. So let's begin. All right, so we are going to, first of all, look at the first problem, F41. All right, now from the problem, we are to determine the moment of what? The force about point O. All right, I think in all the scenarios, we would have to find the moment of the force about O. Okay, so let's begin from that problem. All right, so there we are with the problem. How can I find the moment of this force about O? It's pretty much simple. We have to use what we call the principle of moment. So the principle of moment, and the principle of moment is saying that I have to first of all resolve this force into components, that is the X and Y component, and then I will take the individual moment, which will be the same as the resultant moment. So if I resolve this force, the Y component is going to be what? 100 multiplied by 4 on 5. And the X component is going to be 100 multiplied by, no, the Y component is going to be 3 on 5. And the X component is going to be 4 on 5. So what is 100 on 3 on 5? Let's pick our calculators. 100 multiplied by 3 on 5. So that is 60. It means that the Y component of this force is 60 newtons. Similarly, the X component is going to be 100 multiplied by 4 on 5. That is 80. It means that the X component is 80 newtons. Now, the principle of moment is saying that instead of just finding the 100 newtons directly about O, I would resolve this force and find the individual moments. All right. So this is what we want to say. Summation of moment about O. Then I will choose a convention. Let's say counterclockwise is positive. Is that right? Every moment which is counterclockwise is positive. All right. So now we also have to resort to what we call the principle of transmissibility. The principle of transmissibility. All right. So if I want to find the moment of the 80 Newton force about point O, what I will do is that I will draw the line of action of the 80 Newton force. So you see that the line of action of the 80 Newton force is this line. Then you want to ask yourself, what is the perpendicular distance from this point to meet this line? And that is this distance. Matter of fact, that is the 2. Therefore, the moment, so what we are trying to say is that the principle of transmissibility is saying that I can even bring the 80 Newton force here, since it is on the same line of action. And the moment arm is 2. Now, this moment is going to cause a rotation in this sense. And this sense is what? Clockwise. So it's going to be minus 80 multiplied by 2. Similarly, with the 60 Newton force, the line of action of the 60 Newton force can be thought of as this. So what this means is that I can even bring the 60 Newton force here. And that is actually the principle of transmissibility. I can always trace the line of action of a force on a straight line. Therefore, the perpendicular distance from the origin to meet this is actually the distance here, which is 5. And then this moment is going to also turn in this direction, which is the clockwise. And so I'm going to do minus 60 and into 5. Okay. Now, if I want the summation, it's going to be minus 80 multiplied by 2 minus 60 multiplied by 5. And this is minus 460 Newton meter. You know, the minus sign is just telling us that the resultant moment about O is actually clockwise, because we said counterclockwise should be positive. Therefore, our moment is what? Newton meter clockwise. Or I can also say that CW, the same thing, clockwise. All right, so that is the first problem. So I hope the concept is clear. Let's move on to the second problem. So this is the second problem. So we want to look at F. Okay, let's look at it in this way. All right, so let's look at it this way. This is our second problem. And then we are to find the moment about O. All right, so let's solve this problem together. Okay, so that is the problem here. Let's solve it together. So again, we are going to use the principle of moment. So again, we are going to use the principle of moment, and then we are still going to use the principle of transmissibility. Okay, so how can I find the moment of the 50 Newton force about O? How can I do that? Pretty much simple. So this is what we will do. First of all, resolve the 50 Newton force into X and Y component, and that is the principle of moment. So if I resolve the 50 Newton force, I will get a Y component in this direction, and then I'll get an X component in this direction. Now the X component is going to be what? 50 cosine 60. And that is going to be 25 newtons. So the X component is 25 newtons, and the Y component is going to be 50 sine 60. So 50 sine 60. And what is that? 43.3. So 43.3 newtons. Okay. So if I want to find the moment about point O, I would now use the principle of moment as well as the principle of transmissibility. So we'll say that summation of moment about O counterclockwise is positive. All right. Now, using the principle of transmissibility, I can say that the line of action of the 25 Newton force, in other words, the X component, is actually in this direction. Is that right? So the 25 newtons is acting on this line. So I can even bring the 25 newtons here. That's what we are saying. If I want to find the moment of the 25 Newton force, then I need a perpendicular distance to meet here. And that is the distance or the moment arm of this force. Is that right? Similarly, I have to extend the line of action of the 43.3 force in this direction. Is that right? Now, if I do this, then the perpendicular distance from O to meet this is actually this distance here. Is that right? Okay, so how can I get these distances? So I know that this is 100 millimeters. Therefore, I need to resolve this distance. Do you see? The whole of this is what? The whole of this is 200. Therefore, this side is going to what? 200 cosine 45. Is that right? And then this is also what? 100 millimeters. I hope it is clear. Therefore, the moment about O, so let's start with the X component, which is 25. Now, this component is going to cause what? It's going to cause a moment in this sense. Is that right? And the moment in this sense is what? Counterclockwise. And therefore, it's going to be positive. So 25 multiplied by the perpendicular distance. And the perpendicular distance is the distance from here to here. In fact, that distance must be this. Is that right? Which is the 0.2 or 200 cosine 45. All right, let's convert it to meters. So it's going to be 0.2 cosine 45. And that is actually, 0.2 sine 45. And that is the distance here. And that distance must be the same as the distance here. And then which is also the same as the distance here. So what is that? 0.2 sine 45. Zero point 0.141. 0.141. Okay, so I'm done with the 25 Newton force. How about the 43.3? So the line of action of the 43.3 is still on this line, so I can even bring it here. But I need a moment arm, which is the perpendicular distance from O to meet this force, and that is the whole of this distance. Is that right? Which is given by what? By the way, the moment will be in this direction. The moment of this force is going to rotate in this sense. Is that right? And therefore, it's going to be clockwise. We said clockwise will be negative. So 43.3, and the distance all the way from here, what is it? So 0.1 plus 0.2 cosine 45, and then plus 0.1. What do you get? You are going to get 0.341. 0.341. Now, if I find the resultant of this, what am I going to get? So I am going to get what? So that is 25 multiplied by 0.141, and then minus 43.3 multiplied by 0.341. And that is going to give me minus 11.24. So minus 11.24 Newton meter. The minus sign here means that we said counterclockwise should be positive. If I did everything I get and I had negative, then it means the moment or the resultant moment about O is what? Is actually clockwise. So you can either represent it by this, or you can write clockwise. All right, I hope the concept is clear. So we use the principle of moment and we use the principle of transmissibility. Okay, let's look at the next question. So the next question is going to be, right, I want us to look at that problem. Okay. So I'm talking about this problem right here. Okay. So there we are with the problem. All right. So how am I going to find the moment of F again about O? I'm going to use the same principles. So the principle of moment and then the principle of transmissibility. I'm not going to write them again, but I want us to apply them. So we will say that summation of moment about O, counterclockwise is positive, and then we begin. So using the principle of moment, I have to resolve this into X and Y components. Is that right? All right. So I will resolve this force into X component, and the X component will be in this direction, given by what? 300 cosine 30. And what is that? 300 cosine 30. So I'm going to get 259.807, or let's say 259.81. 259.81 newtons. And the Y component is going to move in this direction, and is given by what? 300 sine 30, and that is 150. Is that right? Okay. So now we use the principle of transmissibility. The line of action of this force is here. Is that right? Then the line of action of the 150 Newton force is in this direction. So if I want to find the moment about O, then I want the perpendicular distance that will meet this. In other words, this will also be the distance all the way from here to meet this line of action. Okay. All right. So now let's start with the 2.5. So let's start with this one. So it means I can even bring the force here. Is that right? I can even bring the force here. But the moment about this is going to cause it to rotate in that sense. And that is what? clockwise. We said counterclockwise is negative. Counterclockwise is positive and clockwise is negative. So that is the force, and the moment arm will be this distance right here. And that distance must be the same as this distance here, which is what? So this, if this rod is, if the length of this portion is what? 0.3, then the vertical component is going to be what? 0.3 sine 45. What is that? 0.3 sine 45. 0.212. All right. Now I will just so I'm done with that part. It means that this small portion here must be what? 0.3 cosine what? 45. Is that right? So that is the horizontal portion here. And that is the moment arm of the 150 Newton force. But look at the direction of the 150 Newton force. So the direction is moving in that sense. Is that right? Therefore, it's going to cause a movement in this direction. And that is what? Counterclockwise. So plus what? 150 Newtons multiplied by the moment arm is the whole of this distance all the way here. Are you okay? Because we are saying that the principle says that the principle of transmissibility says that the 150 Newton force is always acting on this line. So I just need a perpendicular distance to meet the force. That's all. And that is going to be 0.4 plus 0.4 plus 0.3 cosine 45. Is that right? And that is what? 0.612 to 0.612. Okay. So what is the moment now? The resultant is going to what? Minus 259.81 into 0.212 plus 150 into 0.612. What is that? 36.72 Newton meter. So this is positive, and therefore it is what? Counterclockwise. So you can either write this or counterclockwise. All right. So we've been able to solve this problem. Let's look at the next problem. Okay, so there we are with the problem. I want us to look at the 4-5. I want us to look at this problem. All right, so how can I solve this problem? The easiest way to solve this problem is to consider, so if this is 30 degrees, we can also say that this is also 30 degrees, alternate angles. Now, the best way to solve this problem is to find the component of this 600 pounds, which is what? Perpendicular. Why are we interested in the component which is perpendicular? Once we know the component which is perpendicular, I will just multiply that component by the distance, and that is it. So if this should be perpendicular, then here must be what? 40 degrees. Do you get the concept? So that if I have 40, 20, and then 30, I'll get 90. So what I'm saying is that we are trying to form a component which will be perpendicular. So that 40 plus 30 plus 50, 40 plus 30 plus 20 will give us 90. If that is the case, then it means that this component here is what? Perpendicular. All right. How can I get the component here? So if I resolve this force in this direction, the components along this, so the component along the bar is here. Do you get it? And that is given by what? So if this is 600, then I'm going to get 600 cosine 40 here. And then this component here might be what? 600 sine 40. Is that right? If I try to resolve this 600 perpendicular to the plane and along the plane. If I do that, what happens is that this 600 sine 40 will be acting along the sense of direction. And so it doesn't really create any moment. However, this 600 cosine 40 is perpendicular to the bar. Therefore, it creates a moment. And then, since the line of action of this 600 cosine 40 is all the time in this direction, I just need a perpendicular distance from here to here. And that distance is the 5. Therefore, the moment about O for this one is going to be 600 cosine 40 multiplied by 5. I hope the concept is clear. And so what is that? I'm going to get 600 cosine 40 multiplied by 5. And that is 2298.13. 2298.13 Newton meter. And this moment is actually going to be in this sense, which is counterclockwise. All right. Or I can just do this. I hope the concept is clear. Okay. So I want us to look at this problem. So this problem is all right. We have to determine the moment of the pulse about O. Okay. Okay, so there we are. How can I solve this problem? All right. So I'll still use the principle of transmissibility and then the principle of moment. But I have just a single force here. So what I will do is that I will try to locate the line of action of this force. And that line of action is actually this line. Let me draw it well so that you can get it. The line of action of this force is this line here. And then we just need a perpendicular distance from O to meet this line. Is that right? And don't forget that if the whole of this distance here is 3, then we can say that, what can we say? Let me clean this. If the whole of this distance here is 3, then I can resolve this 3 into horizontal and vertical components. Now the horizontal component is going to be what? It's going to be 3 cosine 45. What is 3 cosine 45? So 3 cosine 45. That distance is 2.12. It means that the whole of this distance here is 2.12 feet. All right. But then you realize that if I trace the line of action here, don't forget that the whole of this distance here is 1 feet. Therefore, this will also be 1 feet. Therefore, the remaining portion here will be 2.12 minus 1 feet. And what is that? So if I do 2.12 so if I do 2.12 minus 1, I'm going to get what? 1.12. And that is the distance over here. It means that this small distance here must be 1.12. If that is the case, then the moment arm is going to be this whole distance, which is 4 plus what? 1.12. And the moment is going to come in this direction, which is counterclockwise. Therefore, the moment about O is going to be 600 pounds multiplied by 4 feet. Multiplied by 4 feet plus 1.12. Therefore, we are going to get 600 multiplied by 4 plus 1.12. What is that? 3072 pound feet. And this moment is counterclockwise about O. Or we can also write counterclockwise. I hope the concept is clear. All right, let's solve the last problem. Then we end. All right, so I want us to look at this problem. And in fact, that is this one. So I want us to look at this one. And that will be the last problem I'll solve in this video. All right. So that is it here. So let's solve this problem. How am I going to solve this problem? You know, the line of action of this force is in this direction. Is that right? Therefore, using the principle of moment, I can resolve this force into what? X and Y component. Is that right? The X component is going to what? 500 cosine 45, which is 353.55. Is that right? And then the X component, or the Y component is going to also be sine. So sine 45 is the same thing. Okay. So 353.55. But the issue is, if I use the principle of moment, summation of moment about O, counterclockwise is positive. You know what? What will happen is that since this force is passing through the line of action of O, or passing through the point, it does not create any moment. However, this force is going to be perpendicular, and the distance here is the same as the radius. Therefore, the moment is going to be 353.55. Then I will multiply this by 3, which is the distance from here to here. This force will contribute to 0 moment because the line of action of the force passes through the point. And therefore, that is our moment. And this is going to what? 353.55 multiplied by 3. What is that? 1060.65. 1060.65 Newton meter. And this moment is going to cause counterclockwise about O. So we can either do this as counterclockwise or we'll write it. So thank you very much for watching. That is the end of the problems.